According to OSHA 29 CFR 1910.307, a classified area is defined as an area in which an explosion or fire hazard exists or may exist because of the presence of flammable or combustible dusts, fibers, or gases. Combustible liquids have a flash point at or above 100 degrees Fahrenheit, which is 37.8 degrees Celsius, while flammable liquids have a flash point below 100 degrees Fahrenheit, or 37.8 degrees Celsius. Jet fuel has a flash point ranging from 110 degrees Fahrenheit to 150 degrees Fahrenheit. Therefore, it is considered a combustible liquid. NFPA 30 and the NEC do not specifically address jet fuel. However, they provide guidance on classifying areas where flammable and combustible liquids are handled. NFPA 497, which is the recommended practice for the classification of flammable liquids, gases, or vapors, and of hazardous classified locations for electrical installations in chemical process areas, is a specific standard that addresses the classification of areas where flammable and combustible liquids are present. While jet fuel is combustible, it does not readily vaporize and create explosive atmospheres like gasoline or avgas. However, it is still a potential fire hazard and should be handled with caution. The Material Safety Data Sheet, or MSDS, warning to be kept away from heat, flame, and sources of ignition suggests that jet fuel can ignite if exposed to high temperatures or open flames. Therefore, it is prudent to classify the fuel farm as a Class 3, Division 2 area under NFPA 497. This classification indicates that the area is not likely to contain flammable vapors in normal operation, but may be subject to ignition in the event of equipment failure or leaks. The fuel farm should be equipped with appropriate fire detection and suppression systems. Electrical equipment in the classified area should be rated for Class 3, Division 2 hazardous locations. Personnel working in the classified area should be trained on the hazards of jet fuel and safe handling procedures. Based on the available information, it is recommended to classify the fuel farm with 4 underground 20,000-gallon tanks of jet as a Class 3 Division 2 area under NFPA 497. This classification ensures appropriate safety measures are implemented to minimize the risk of explosions or fires. Let's delve into a more detailed exploration of classifying areas with combustible liquids, focusing on jet fuel within the framework of OSHA, NFPA, and the NEC. Firstly, understanding the fundamental definitions is crucial. As previously mentioned, OSHA 29 CFR 1910.307 defines a classified area based on the potential for fire or explosion hazards due to flammable or combustible substances. The key differentiator between flammable and combustible liquids lies in their flash points. Flammable liquids have a flash point below 100 degrees Fahrenheit, meaning they readily produce vapors that can ignite at relatively low temperatures. Combustible liquids, on the other hand, have a flash point at or above 100 degrees Fahrenheit. Jet fuel falls into the combustible category with its flash point ranging from 110 degrees Fahrenheit to 150 degrees Fahrenheit. This distinction is significant because it influences the likelihood of vapor formation and subsequent ignition. Now let's consider the role of NFPA 30, the Flammable and Combustible Liquids Code, and the NEC, the National Electrical Code. While neither document explicitly addresses jet fuel, they provide comprehensive guidance on handling flammable and combustible liquids in general. NFPA 30 outlines requirements for storage, handling, and use of these liquids, including ventilation, fire protection, and spill control measures. The next, specifically Article 500 and subsequent articles, addresses electrical equipment and wiring in hazardous classified locations. These locations are categorized based on the type of hazard present, such as flammable gases, vapors, or combustible dusts, and the likelihood of the hazard existing under normal or abnormal conditions. NFPA 497, recommended practice for the classification of flammable liquids, gases, or vapors and of hazardous classified locations for electrical installations in chemical process areas, provides a more detailed methodology for classifying areas where flammable and combustible liquids are handled. It takes into account factors such as the properties of the liquid, the quantity handled, the ventilation conditions, and the potential for releases. Given that jet fuel is a combustible liquid with a relatively low vapor pressure, the potential for vapor formation under normal conditions is limited. However, it's crucial to consider scenarios where vapors could be present, such as during spills, leaks, or elevated temperatures. The MSDS for jet fuel emphasizes the need to keep it away from heat, flame, and ignition sources, underscoring its potential to ignite under certain circumstances. Based on these considerations, classifying the fuel farm as a Class 3, Division 2 area under NFPA 497 is a prudent approach. Class 3 locations involve the presence of easily ignitable fibers or flangs, but since we're dealing with a liquid, the more relevant aspect is Division 2. A Division 2 location is one where volatile flammable liquids or flammable gases are handled, processed, or used, but in which the liquids, gases, or vapors are normally confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment. Also, Division 2 includes locations where ignitable concentrations of flammable gases, flammable liquids produce vapors, or combustible liquids produced vapors are normally prevented by positive mechanical ventilation, and which might become hazardous through failure or abnormal operation of the ventilation equipment. It is important to understand the implications of this classification. Firstly, it necessitates the use of electrical equipment specifically designed and rated for Class 3, Division 2 hazardous locations. This equipment is constructed to prevent ignition of flammable vapors that may be present. Secondly, it requires the implementation of appropriate fire detection and suppression systems, such as fire alarms, sprinkler systems, and portable fire extinguishers. Thirdly, it mandates that personnel working in the fuel farm receive comprehensive training on the hazards of jet fuel and safe handling procedures, including spill control, fire prevention, and emergency response. Now, let's discuss additional considerations for ensuring the safety of the fuel farm. Ventilation is a critical factor. While jet fuel does not readily vaporize, adequate ventilation should be provided to prevent the accumulation of vapors in confined areas, particularly during spills or leaks. Ventilation systems should be designed to effectively remove vapors and prevent them from reaching potentially hazardous concentrations. Spill containment measures are also essential. The fuel farm should be equipped with secondary containment systems such as dikes or berms to prevent spills from spreading and contaminating surrounding areas. These containment systems should be designed to hold the entire volume of the largest tank plus an allowance for precipitation. Regular inspections and maintenance are crucial for identifying and addressing potential hazards. Tanks, pipelines, valves, and other equipment should be inspected regularly for leaks, corrosion, and other signs of deterioration. Any deficiencies should be promptly repaired to prevent spills or releases. Grounding and bonding are important for preventing static electricity buildup, which can be a source of ignition. All metallic components of the fuel farm should be properly grounded and bonded to dissipate static charges. Signage and labeling should be used to clearly identify the hazards associated with jet fuel and to provide instructions for safe handling. Warning signs should be posted in conspicuous locations to alert personnel to the potential for fire or explosion. Emergency shutdown procedures should be established and clearly communicated to all personnel. These procedures should outline the steps to be taken in the event of a spill, fire, or other emergency. Finally, it's important to consult with qualified professionals such as fire protection engineers and hazardous materials specialists to ensure that the fuel farm is properly classified and that appropriate safety measures are implemented. They can provide expert guidance on compliance with applicable codes and standards and can help to identify and mitigate potential hazards. In summary, while jet fuel is a combustible liquid that does not readily vaporize, it still presents a potential fire hazard. Classifying the fuel farm as a Class 3, Division 2 area under NFPA 497 is a prudent approach to ensure that appropriate safety measures are implemented to minimize the risk of explosions or fires. This classification necessitates the use of specialized electrical equipment, fire detection and suppression systems, and comprehensive personnel training. Additionally, proper ventilation, spill containment, regular inspections, grounding and bonding, signage and labeling, and emergency shutdown procedures are essential for maintaining a safe operating environment. By adhering to these guidelines and consulting with qualified professionals, the fuel farm can be operated safely and in compliance with applicable codes and standards. Furthermore, let's expand on specific aspects of electrical safety within a Class 3, Division 2 environment as it pertains to a jet fuel farm. Electrical equipment installed in such locations must be designed and certified to prevent ignition of flammable vapors or combustible dusts that might be present. This involves several key design features. Firstly, explosion-proof enclosures are used to contain any potential ignition within the enclosure, preventing it from propagating to the surrounding atmosphere. These enclosures are robust and designed to withstand the pressure of an internal explosion. Secondly, intrinsically safe circuits limit the electrical energy to a level that isn't sufficient to ignite flammable vapors or combustible dusts, even under fault conditions. This is achieved through the use of specially designed components and circuits that limit voltage and current. Thirdly, dust ignition-proof enclosures are designed to prevent the ingress of combustible dusts, ensuring that they do not accumulate on hot surfaces and create a fire hazard. In addition to equipment design, proper installation is critical. Wiring methods must comply with the NEC and ensure that there are no potential sources of ignition such as exposed conductors or loose connections. Conduit systems should be sealed to prevent the ingress of flammable vapors or combustible dusts. Regular inspections and maintenance are essential to ensure that electrical equipment continues to operate safely. Inspections should include checking for loose connections, damaged wiring, and corrosion. Any deficiencies should be promptly repaired or replaced. Now, let's consider the specific types of electrical equipment that might be found in a jet fuel farm and the requirements for their use in a Class 3, Division 2 location. Lighting fixtures must be rated for hazardous locations and designed to prevent ignition of flammable vapors or combustible dusts. This typically involves the use of enclosed and gasketed fixtures with explosion-proof or dust ignition-proof ratings. Motors used to drive pumps, fans, or other equipment must also be rated for hazardous locations. These motors are typically enclosed and designed to prevent sparking or overheating. Control panels and switchgear must be housed in explosion-proof enclosures to contain any potential ignition. These enclosures must be properly sealed and maintained to ensure their effectiveness. Wiring and cabling must be suitable for hazardous locations and installed in accordance with the NEC. This typically involves the use of rigid metal conduit or cable with appropriate fittings and seals. Grounding and bonding are essential for preventing static electricity buildup, which can be a source of ignition. All metallic components of the electrical system must be properly grounded and bonded to dissipate static charges. In addition to these specific requirements, it's important to follow general electrical safety practices such as wearing appropriate personal protective equipment, de-energizing equipment before working on it, and using qualified electricians for all electrical work. Furthermore, consider the importance of ongoing training for personnel working in and around the fuel farm. Training programs should cover not only the hazards of jet fuel and the proper handling procedures, but also the specific requirements for electrical safety in hazardous locations. Personnel should be trained to recognize potential electrical hazards, such as damaged wiring or malfunctioning equipment, and to report any concerns to qualified personnel. Training should also cover the proper use of personal protective equipment and emergency procedures in the event of an electrical incident. By implementing these electrical safety measures and providing comprehensive training, the risk of electrical incidents in the jet fuel farm can be significantly reduced. It's important to remember that electrical safety is an ongoing process that requires vigilance and attention to detail. Regular inspections, maintenance, and training are essential for ensuring that the electrical system continues to operate safely and reliably. In conclusion, classifying a jet fuel farm as a Class 3, Division 2 location under NFPA 497 necessitates a comprehensive approach to electrical safety. This involves the use of specialized equipment designed and certified for hazardous locations, proper installation practices, regular inspections and maintenance, and comprehensive personnel training. By adhering to these guidelines, the risk of electrical incidents can be minimized, and the safety of personnel and the environment can be protected.